And we're live. So, hi everybody. I'm really excited having you all here today to learn about Kubernetes cost management, cost efficiency, and sustainability. I'm going to give now it's just 1 minute from the start of the webinar. We're going to give it another 2, and we're going to start. In the meanwhile, let's wait. We have also we have Ro'i and Vanessa joining us. I'm gonna introduce them all shortly. So again, thank you for coming. If anyone has any question, you can do. We can do. I'm telling also Vanessa and Ro'i. We can do polls if you have a question. Everybody can ask questions in the chat. So feel free. I'm gonna give it another minute. I'm gonna be quiet, and we'll start. Okay, I think we're good. So again, hi everybody. Welcome to the joint webinar by Liquid Reply and Finout, talking about Kubernetes cost efficiency, what the challenges are, what's going on in the world, and obviously some optimization tips. We got with us the wonderful and amazing Vanessa. She's gonna brief you a little. She's a manager, trainer, and speaker of FinOps and GreenOps in Liquid Reply. She's gonna introduce you to the main challenges of what's going on in the world and give you her perspective of some of the in the trenches, helping customers really entangle the cost challenges. And in the second half, we're gonna have our own CEO and co-founder Ro'i Ravon, who's gonna give you some awesome tips and tricks on how to reduce your waste and manage your cost more efficiently. And if you have any questions, feel free to ask them or use the chat. And we can also do some polls. It's gonna be fun. I'm gonna get out of your hair, Vanessa. Hi.
Hi. Thank you. Are you sharing? Sorry, I have to ask that.
Share.
Good.
Give me a second. I just need to figure out how to share here. I didn't. Here it is. Share screen. Wait a minute. Here we are. Can everybody see my screen?
I mean, I can. So
okay, so if you can,
I guess.
I think.
Thank you for the introduction and also for the invite. Please, as you also said, just if you have questions, post them in the chat. If you see them during the presentation, we can directly answer them, or maybe later. Depends. But today is all about the environment. And I mean, it's about Kubernetes and the environment, so it's about IT. And the IT nowadays, it's not just like that small decimal digit at the end of the equation. When we talk about the global greenhouse gas emissions, here on the slide, you see that the IT is currently dealing 4% of the carbon emissions of the global greenhouse gas emissions. I mean, 4%, that's actually a lot worldwide. And that number is actually growing because, I mean, as you know, public cloud spend is growing, container spend, Kubernetes spend is growing, and the IT itself as well. Correctly, like last year, the cloud spend was about $500 billion US. And I think all of those, like Gartner and co, they estimated a number, and that the actual number was even larger than the estimation. And to be honest, I expect that to be similar in the next couple of years. So we will see a lot more cloud spend and a lot more greenhouse gas emissions produced by the IT. So in addition to that, I mean, sustainability itself, today it's not only a topic for activists and idealists anymore. Sustainability is not an optional topic for really any company that works in and with IT, so actually every company. On the next slide, we see that we have there are a couple of different pillars when it comes to sustainability that are relevant for us as companies. First one is legal requirements. I think in the last years there were a lot of different legal requirements developed and are now being implemented, not only in the European Union, but also worldwide. But only focusing on the European Union, there is this EU taxonomy. And that thing says that companies have to disclose and report on their environmental activities, as well as the impact that has on their numbers. Similar is for the CSRD, that's the Corporate Sustainability Reporting Directive. So that even says like larger companies and all listed companies have to report and disclose all their activities around ESG, so environment, societal, and governmental or governance criteria. So that means, I guess, all of us or most of us working in a larger or any company have or are in touch with ESG at some point. Secondly, the second pillar, as you can see on the slide, is the customer requirements. Last week, I think, I've read a study that now 75%, so like two-thirds, more than two-thirds of the customers, the end users, are eager and keen to buy products from companies that have some impact, positive impact on the environment. And that's a lot. I mean, of course, it's just like they are saying they want to buy from a sustainable company. It's easy to say that very fast. But I think in the long run, it's about that. So all of us have to look that we develop our products in a more sustainable way, else we will lose. Third point, investor requirements. There are already a lot of portfolios and in general investors out there that are just investing into companies that do have an ESG rating. And I personally think that companies without an ESG rating will not find any investors in the long run. So that said, it's really important that we go into that direction. And last but not least, the employee requirements. I mean, there is a lot of talking about the Gen Z, and let's see what comes beyond that. But these people, or the younger generation, they don't want to work for a company that's not sustainable in any way anymore. They want to have this good feeling and also the positive impact on the world. And companies which do not invest in sustainability anymore, they will not retain any young talent in the future. So I would say these four pillars are on like the macroeconomic scale. So companies need to adopt sustainable practices to minimize their impact on the environment. And usually when it comes to IT and the cloud and containers, people say that using these practices already reduces the environmental impact. And in an ideal world, yeah, that's exactly the case. Just using a container saves the world and that's it. But that's when this slide comes in. It's really not the case. So we know that for every $1 million invested in the cloud, 320K are waste. So like 30% of everything you invest in the cloud is just waste. And on the one side, of course, that's financial waste. You will lose a lot of money that you can invest better in, I don't know, new employees, cooler projects, products, or incentives for your colleagues, whatever. But at the same time, it's not only about money, it's also waste for the environment. It's unused resources that could have been used better somewhere else. To be honest, most companies do not know they have that waste because there is not a lot of transparency, and we will talk about transparency in a minute again. But as soon as the companies know, they cannot look away anymore and they need to dig into that waste and need to improve it. And yeah, the question is, where does that waste origins from? And there are actually 4 points. The first one is over-provisioning. I mean, as it is with container, it's super easy to allocate resources to applications. But at the same time, if these allocations are too high, that's called over-provisioning, and that's just a waste of administering Kubernetes or working with Kubernetes are not aware of the requirements of the applications. Secondly, poor resource utilization. That's a bit similar to over-provisioning, but the thing is, Kubernetes scales very dynamically. Containers itself, everything is optimized, hopefully. But at the same time, applications are not using their fully allocated resources. And then we have like that poor resource utilization where, for example, we only use 5% of the CPU that we've allocated. Third point is zombie resources. I've already said it, applications are scaled up and down and vertically, horizontally, whatever, automatically. And sometimes some resources are left behind, such as, for example, storage volumes, or maybe orphan pods. That also happens from time to time. And these zombie resources are, again, waste. And lastly, there is a lack of monitoring and optimization. I said it a bit before, it's all about transparency, and for that you need monitoring and optimization in general, but especially when it comes to containers, it's a bit tricky to set it up properly. Okay, what can we do about that now? How to prevent waste? So again, on a higher level, we have 4 different options. First one, right sizing. We can optimize our pods, optimize our nodes and our cluster overall, and use only and exactly what we need. Second, auto-scaling. I mentioned it a few times. Automation is key when it comes to containers, and auto-scaling is one of these automation behaviors that we really need to leverage to prevent waste. Then the third point is resource quotas, and I even want to extend that to not only include resource quotas, but also resource requests and limits. So with the latter, it's about giving your pod only the minimum and maximum resources that it really needs ever in its life. And the resource quotas make sure that one product or one team only gets a specific amount of resources, that share is fair, kind of. And then the fourth point is reusing of containers. What's meant by that is just reuse of a proper configuration. So once you found it, you have some infrastructure as code probably, and a well-working, well-configured deployment, and you can reuse that, or you should reuse that in the future. Because that's already working and set up, so why not just reuse it again? That's the theory and the high level, but how can we do that? We need to dig a bit deeper. And that's when Roy comes in.
Awesome. Thank you, Vanessa, so much for all the insights. Let me share my screen here for a second. All right, so to build up on all the super interesting insights that Vanessa shared, like Kubernetes is very complicated, and it brings us multiple different aspects of complexity into our cloud environment. So when we're thinking about Kubernetes, right, there's obviously the good stuff, right? So Kubernetes brings us scalability that we could only dream of a few years back, portability. So we don't really care where we're running our environment. As long as we have a container, we can just launch it to any Kubernetes cluster out there, regardless of the cloud that is hosted. And Kubernetes is auto handling lots of resiliency stuff, so we don't need to monitor our services. And I have like some sort of self-healing kind of protocols, because Kubernetes can just reschedule the pod if something is happening. So it brings us lots of good stuff. But also on the other hand, like Kubernetes opens vast amount of problems that we started to invent for ourselves. So because of that, so clusters are a lot more complicated to manage than just a single instance. Kubernetes has a very steep learning curve. It's very hard to get into the Kubernetes jargon in order to install whatever, and to make sure that we're thinking in a Kubernetes mindset. And obviously the operational overhead, we don't just manage an OS now, we manage an OS that manage another set of abstraction on top of it. So we now have an abundance of complications that keeps on giving. And on top of everything, the ugly part is the cloud cost. It is obviously associated with it, and other than just a waste of money, as a big part of it that Vanessa talked about before is the carbon emission and waste that we're just throwing away. Let alone the company money, we're just overusing resources that we don't really have to, and really hurting our environment just by running Kubernetes, in an unmanaged or unoptimized way. So thinking about Kubernetes, we have four main cost challenges and one bonus one. So the first thing is optimizing the utilization. I'm going to touch about it in a minute. Is an extremely hard problem. It just gets more and more complicated because, again, we now have two sets of stuff that we need to manage, and not only the operating system level. Cluster sizing is a very big problem, and for all the computer science graduate, it's an NP complete kind of problem, right? So we have a binsec that we can really fill in the most optimal way. So we always, Kubernetes is designed to have waste in it built in. It's a very, very difficult problem in order to get to the proper sizing of Kubernetes clusters. Storage and networking configuration starts to be significantly more complicated than it was on a host, because suddenly a pod can migrate between different hosts, and obviously Kubernetes helps us a lot with that, but it still adds another level of complexity when managing the cluster. And we need to make sure that running Kubernetes and containers at scales, we need to treat them as if we were instances in the cloud provider that we just treated before. So we need to tag them properly using labels. We need to make sure that we have the proper hierarchy of cost management. And on top of all, Kubernetes is now, as we mentioned before, very easy to run multi-cloud at. So if we solve that entire problem for AWS, we now need to solve it again for GCP, and we need to solve it again for Azure, and just getting another multiple levels of complication on top of everything. So essentially, our visibility significantly drops when migrating to Kubernetes, because now we're getting bills from the cloud providers, but the bills from the cloud providers are speaking in the instance level, but we're running pods and running everything on top of it. So our complexity is increasing and the visibility is dropping. So we start to get, to end the day with more questions than what we have answers for, right? So our AWS bill went up, but why? Or is it good or not good? Does it have any connection to reality? What is the waste factor of it? How much money are we just throwing away every month? What's the carbon emission that we're, just contributing without any business justification to doing that? Why, as I mentioned before, we're paying in instances, but we're running pods. So how can we translate them both? And when we're done, we need to start to allocate the cost. So how much did we spend per team? How much did we spend per environment, per resource, per customer, per whatever? So all of the questions that partially answered on when just running on bare metal cloud instances now start to get again. So what can we do? A few, actual and actionable tips and stuff that we can do that Vanessa spoke about before. So first, we need to really think on what's the resources that we need to ask when running Kubernetes, because the folks that actually are setting those are the developers that develop the service. So when we're developing a new service, we never really know how much resources are we gonna need, and as an engineer, we tend to want to sleep at night, so we just over provision all of the resources. And it's perfectly okay to do so when we're just launching a new service. We don't really know what's going to be the consumption, so that starts with a bit over provisioning, and then we can right size it afterwards. The issue is that the afterwards section just never shows up because we continue to go to the next Jira ticket, and we have another task, and we never come back to optimize. So it's really important to do that after the fact, and to spend time in figuring out what's the actual consumption of the service that we use, what RAM did we actually use, what CPU did we actually use, and that way we can start to make the pods, as efficient and as small as we can, because this is the Kubernetes best architecture. So now we have a very efficient pods that we can talk about in the next slide to start to scale. So right size request, right size all of the configuration, and we need to be very flexible with what we can do.
Can I chip in here for a second?
Yeah, of course.
Thank you. So because you mentioned that it's difficult, especially at the beginning of a software product lifecycle, to have the correct resource requests and limits, and what helps there is really have load tests running before you do anything. And with these load tests, you can finally sleep well at night, because you know what the maximum and hopefully also the minimum of resources that your application needs is. Of course, you should and you have to redo those load tests, but what Roy said, it's tricky to iterate over that. So sometimes that gets lost. So just make sure that you get it right in the beginning, and you're already better off than before.
I can't reiterate it enough. I mean, load testing is something that we often overlook as software software companies, and it's super important both for cost management, for efficiency, for really understanding bottlenecks, understanding degradations. It's super important. So when possible, always load test. But even if you load test it, you always need to check in production, because production workload might be a bit different than what we hoped. So always continue to reiterate that. So now that we have those very efficient pods, the beauty of Kubernetes is that it allows us to scale up and down in a matter of seconds usually. So we don't need to over provision an instance, like we used to in AWS, because the scaling time was a few minutes kind of factor. So when you scale in a few minutes, you need to have extra capacity ready for a rainy day, so we can start to support the workloads that you should. With Kubernetes, it can be milliseconds or seconds, depends on the way that the service is built. But launching new services is very easy, and it's a best practice in Kubernetes environments to build very small pods and just scale the number of replicas of that pod that we need to support all the workloads. So we can do it both horizontal and vertical, but it's very important to invest time in a proper autoscaler, because this can save an insane amount of money, because we never just spin up resources that we don't need, and we only use them on demand, and we can just use the same set of resources, which is the beauty of Kubernetes, right? So we can use the same nodes in order to host different set of pods, and now we're running a reports mechanism, so we can launch a bunch of pods that that's gonna trigger a scheduled report, and now we need to deal with the query. Now we need to deal with a bunch of ingestion pipelines or whatever. So we can always just pick the right set of pods that can utilize our Kubernetes clusters and be very efficient with our resources, and don't waste lots of time on scaling or on over provisioned pods. Vanessa, do you have anything to add in that?
No, I fully agree with that. So someone mentioned in the chat that you can also use the VPA before doing load tests, or if you're unable to set the resource requests and limits in a proper way, just use the VPA. Oh, that rhymes. I think that's good. Yeah, so yes, you can also do that. But auto-scaling and the whole automation part is essential when it comes to containers. I mean, it's not possible to do that manually. Way too much effort.
Yeah. And for the last section, when we very efficient with the pod scaling, we can now scale the cluster accordingly based on what we know. So there's a bunch of newer kind of technologies out there. Carpenter being one of the most dominant examples here that can help us predict and even utilize the right resources within the cloud environment based on this type of resources that we need at any given moment. So for Thursday afternoon, the spot prices for a specific instance type might be cheaper than on demand of instances we had before, right? So we can always pick and choose between different kinds of technologies and make sure that we're utilizing the best available resources that we can get from the cloud provider based on the demand, and pick and choose and scale based on that. And now we have a disconnection between our workloads and the infrastructure that hosts it, and we have two different levers we can play around with, and we don't need to look at it as just one kind of current hardening, because I seen personally multiple companies that adapting Kubernetes, but they have they're scaling with one node, and each node has just one pod that utilizes the entire node. So it kind of beats the point. So it's very important to disconnect between the two and be able to scale for each one.
Maybe to add to that, especially when we use autoscaling, it helps, of course, a lot with the optimal resource allocation and everything. But at the same time, we really need to make sure that we do not lose the transparency. So we need to have some mechanism in place, maybe namespaces or maybe tags for each pod that makes it possible to allocate the resources back to a team. Because else, if we have a problem and we see a pod is not maybe using too much resources, we don't know whom to talk about and how to fix it.
100%. Labeling is key for everything. Even if you don't need it now, label ahead. It's going to be significantly easier. So we wanted to show you a quick demo on Finout and on Finout and what the Finout can do for Kubernetes management. So first, it's very important, as we talked about before, to show Kubernetes cost. And with Kubernetes, we can bridge that gap between what we actually got from the cloud provider, which is the actual cost and usage report for AWS or the Beam console or whatever, and then match it with the actual Kubernetes pod utilization. So we can look at Prometheus or Datadog. You don't even need to install any agent, and then we can just fetch the metric in order to break it down based on different cost parameters. So you can see the cost per cluster, per namespace, per each deployment, each label, whatever. When it comes to cost optimization, the after the fact kind of resource optimization is very important to do. So as we can do, as we talked about before in Finout, we can analyze Kubernetes resources, after running in production, and we can tell you we can see that you asked 6,000 megabytes of memory, but you never use more than 2,000 or whatever, in the less couple of days of period. And same with CPU, you requested 2 cores, but you never used more than whatever. So we can tell you exactly how much money you can save based on optimizing those kinds of parameters. And after we right-size the pods, we can start to go ahead and right-size the actual instances. We can buy saving plans. We can see what's idle and right-sizing do we have on the instances that running that Kubernetes environment. And then we have the ability to to select and pick the right set of technologies in order to to run it fully optimized and with as low as possible carbon footprint, obviously as well. Q&A. Yoav.
Wait a minute. Here I am. Hop. So first of all, if anyone has any questions, now's the time. Feel free. I wanted to ask from things that we've seen in the past on chats and Slack channels regarding what's the usual amount of waste. I'm asking both of you, by the way, the usual amount of waste customers are when they start managing the cost, the percentage, and after like a couple of months of actually implementing those tips, and obviously more, how much can they anticipate in reduction? Vanessa.
Yeah. So actually, there was this one study, and I think it was also shown on the slide, that it's about 30%, a bit more. And based on my project experience, that really is the case. Usually it takes like 3 to 6 months to get a hold of that waste. And I mean, 30% is really like a high benchmark, I would say. So I think if you're good, you manage to reduce it by 30% after 6 months. But I think like something in between 15 to 30 is, based on my experience, something that's really realistic. And depending on your cloud spend or your container spend, that can be a lot.
And is that connected directly into sustainability and carbon footprint? Like saving 30% of waste is saving 30% of carbon footprint?
Yeah, unfortunately, it's not like a direct connection, but yes, if you save 30%, you will absolutely save some percentage of CO2 as well. It depends a bit on the region where you deployed your nodes, for example. Depending on the region, there are different carbon emissions associated with. So depending on that, you will probably save more or less CO2. Yeah, but there are tools like cloud provider help you with tools. There are also open source tools that show you an estimation of your carbon emissions. For now, there is not a defined calculation yet. I'm sure that's in development, but not there yet. But those tools can help you, to get a feeling for it.
Okay, fantastic. I see that we have one question. Let's see if it's something. What is the optional amount of resource waste, considering upscale times for instances, for example? Wait.
I'm not sure I understand the question. Optional amount of resource waste? Can you clarify, Christoph? Or Vanessa, if you...
Yeah, I'm not 100% sure. I got the question, but...
Okay, so I'll write him. Can you please elaborate? And we can answer to the second question.
Yeah, so can Finout be used for OpenShift? Yeah, so as long we can monitor the Kubernetes layer on top of beneath OpenShift. So OpenShift is just one scheduling kind of environment on top of it. So I really in general, yes.
So yes. Okay, fantastic. I see that Christoph did not expand his question. I think that it's
he brought in the chat optimal amount of resource waste. He meant optimal.
So optimal amount is as low as the service needs. So if you constantly use one CPU in order to run some sort of calculation, so one is the optimal amount. So it really depends on the type of workload. So optimal is just what you're using in a consistent manner, and not 1 gig of RAM on top of that.
Fantastic. So first of all, I want to thank Vanessa and obviously Roy, but we work together. So I want to thank Vanessa for agreeing to talk to us today.
Thanks for the
For sure.
Thank you, Vanessa.
And secondly, we're heading, the three of us are heading next week for KubeCon in Amsterdam. So if you're there, feel free to hop in and say hi, and we can talk in depth about everything Kubernetes, cost management, waste, sustainability, and much more. Thank you very much for your time.
Thank you.
Thank you so much, Vanessa.
Have a great day.
Yeah. Bye-bye.